Good morning. Today in this session, let us start the unit 4, that is learning, and in this learning especially we are going to discuss about the machine learning paradigms. Coming to learning, learning is one of the fundamental building blocks of artificial intelligence solutions. In this learning we can discuss or we can explain in two ways. One is from a conceptual standpoint and from a technical point of view. And coming to from a conceptual point of view, learning is a process that improves the knowledge of an AI program by making observations about its environment. That is conceptual point. And from a technical or mathematical standpoint, AI learning process focused on processing a collection of input-output pairs for a specific function, and it is going to predict the outputs for the new inputs. And learning, it's in simple, we can say that it is the process of converting experience into expertise or knowledge. To understand this different types of AI learning models, mainly we are going to use two elements of human learning process. One is the knowledge and other one is the feedback. From the knowledge perspective, we can say these learning models classifies based on the representation of input and output data points. And coming to in terms of feedback point of view, AI learning models can be classified based on the interactions with the outside environment, users and other external factors. This is just a simple block diagram of this learning system, and we have mainly four components. One is the critic, other one is the learning element, problem generator and the performance element. And when we can say this as a learning agent, it is going to perceive from the environment and effectively acts with the help of sensors and effectors. But to make use of these things, this learning agent requires these main four components. Let us discuss one by one what are all these components of this learning system. First one is the performance element. Here the performance element is the agent itself that acts in the world. It takes, perceives and decides on some external actions. Then coming to the next one is the learning element. Here it is responsible for making improvement, takes knowledge about performance element and some feedback and determines how to modify this performance element based on the feedback. Next one, critic. It's a very important component of this particular learning element. Tells the learning element how agent is doing, whether it is success or failure, by comparing with a fixed standard set of performance. It will gives that a particular learning agent is success or failure, just comparing with a fixed standard set of performance. Next one is the problem generator. It suggests problems or actions that will generate new examples or experiences that will aid in training the system further. If you want to train the system further, it is going to, this problem generator will suggest our problems or actions that will generate some new examples. Next one is the sensors and effectors. We know that these are the two important things for a particular agent. Both these components are external to the system. The system receives information from the sensors, information or data from the sensors, while the output is transmitted to the effectors. So the input we are going, that learning agent is going to receive from the sensors, and it is going to transmit it through effectors. So these are the main four components of a particular learning element. And next, let us discuss the paradigms of machine learning. Before going to discuss what is exactly the machine learning, before that let us see some of the learning, different types of learning. In this, the first one is the rote learning. What is this rote learning is? It avoids understanding the inner complexities but focuses on memorizing the material so that it can be recalled by the learner exactly the way it was read or heard. In this we have two types. One is learning by memorization, learning something by repeating. So the name itself indicates this learning by memorization, just which avoids the understanding the inner complexity of the subject that is being learned, and instead it focuses on memorizing the material so that it can be recalled by the learner exactly the way he has read or heard from something. Next one is learning something by repeating. That is repeating over and over and again, saying the same thing and trying to remember how to say it. It's just like how we are going to butify a poem or a song or something like that. It all comes under this rote learning. Just repeat over and over. If you want to learn something, just we are going to repeat the same thing over and over again. That comes under learning something by repeating. So this learning by memorization and learning something by repeating both comes under this rote learning. and other one is learning by taking advice. So this is easiest and simple way of learning, and in this type of learning a programmer writes a program to give some instructions to perform a task to the computer. Once it is learned, that is programmed, the system will be able to do new things. Why? Because it's already being programmed. Also there can be several sources for taking advice, such as human experts, internet, or some other sources we can take the advices. And however, this type of learning has more necessity of inference than rote learning. Inference means we know that it is deriving the new conclusions from the existing one. And as the stored knowledge in the knowledge base gets transformed into operational form, the reliability of knowledge source is always taken into consideration when it comes to learning by taking advice. And the next one is AI learning models, that is knowledge based classification. So till now we have discussed one type of learning, now we are discussing other type of learning, that is knowledge based classification. In this, the first one is the inductive learning. This type of AI learning model is based on inferring a general rule, that is from data sets of input-output pairs. And algorithms mainly known as knowledge-based inductive learning, simply we call it as KBIL, is a great example for this type of AI learning technique. And this KBIL is focused on finding inductive hypothesis on a data sets with the help of background information. So it is going to find some hypothesis on a given data sets with the help of some background information. That is what we call it as is inductive learning. And the next one is deductive learning. This type of AI learning starts with a series of rules and infers new rules that are more efficient in the context of some specific AI algorithm. And mainly explanation based learning, simply we call it as EBL, and relevance based learning, RBL, are the best examples for this deductive learning. Whereas this EBL extracts general rules from examples by generalizing the explanation. Okay, it is going to generalize that explanation and it is going to extract the rules from a particular context. Whereas coming to RBL focuses on identifying the attributes and deductive generalization from simple example, where it will going to identify some attributes and it is going to deduct the generalizations from that simple example. So this is what that in the difference between inductive and deductive learning. Let us also will see in detail what are the differences between this deductive reasoning and the inductive reasoning, or deductive learning or inductive learning. Coming to this deductive learning or reasoning, it is a form of valid reasoning to deduce new information or conclusion from known related facts and information. So it is going to deduce the new information, or it is going to derive the conclusion from known related facts. Whereas this inductive reasoning arrives at a conclusion by the process of generalization using specific facts or data. So it is arrives directly at a conclusion just by the process of generalization, whereas it is going to deduce the new information from the existing one. That is what the first difference between this deductive and inductive. And next one is approach. What approach will follow for this deductive reasoning is top-down approach. But whereas coming to inductive, it is bottom-up approach. Why? Because it starts from conclusion. That's why that is bottom-up approach. Whereas it is going to start from the premises or hypothesis. That's why we call it as the top-down approach. And here, that's what, see here, the deductive reasoning starts from premises, that is from the assumptions it will start, and it is going to derive a conclusion. That's why the approach is top-down approach, whereas inductive reasoning starts from the conclusion. From the conclusion, it is going to go to the facts. That is why we call it as the bottom-up approach. And in deductive reasoning, conclusion must be true if the premises are true. But whereas coming to inductive, the truth of premises does not guarantee the truth of conclusion. Why? Because it starts from the conclusion, so it doesn't guarantee that the truth of premises should be true, the truth of conclusions. And here, use of this deductive reasoning is difficult. Why? Because we need facts which must be true, but there is no guarantee the facts what the given is true. That is what the usage of difficult for this deductive reasoning. But whereas coming to the inductive reasoning is fast and easy. Why? Because as we need evidence, only just we need evidence instead of true facts, and often we can use it in our daily life. So the usage is very easy coming to inductive reasoning. Why? Because it's just only need the evidence, whereas this one is just we need the truth, facts. And coming to this last difference, deductive reasoning reaches from general facts to a specific facts, but whereas inductive reasoning reaches from specific facts to a general facts. So that is what the difference. General facts to specific facts, and it is specific facts to general facts. These are the some of the differences between this deductive reasoning and the inductive reasoning.